Okay. So we are talking about data structures, right? So data structure, or they're called as collections in, okay, in Python. Okay, collections means more than one element. That's what. So we have string, and we have list. You have tuple, which is immutable version. So exactly, which is like list, but it is immutable version of list, and then dictionary. Okay, in this series, the last topic is your sets. So that's what we'll do today. Now, you must have done these sets in your maths class before. Okay, so there is a special usage of set. Okay, the usage of set is that it is used to count the elements. Now, if I ask you to name 5 fruits, right? Now, let's say you name apple, banana, mango, orange, cherry, whatever. Now, the order in which you uh, answer me doesn't really matter, isn't it? Right? So, whether you say apple, banana, mango, or you say mango, banana, apple, doesn't matter. As long as you are giving me 5 unique names. Okay. So, that's why first property of set is that there is no order. Okay, there is no order, so there is no first element or second element in list. It is just a representation, right? Sets are used to represent. The order doesn't matter. Okay, it just says that it is there. Okay, now if I ask you to name 5 fruits, both of you, and let's say if you give me same names, maybe in different order, so are your answers different? No, your answers are still same, because you're giving me same 5 names. Doesn't matter in which order you give me. Okay, so that's the first property. Second property of sets is that there is no, or it doesn't allow duplicate. Right? Now, if I ask you to name 5 fruits, you cannot say apple, 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 apple 5 times. Right? Whether you say 1 time or 100 times still means one. That's why I say it's used to represent the value. It is not to um, indicate order or accept duplicate. Right? When I say apple, it means you are representing entire apple. You cannot say, apple of India and apple of US or apple of Fiji. No, doesn't mean that, right? So, so these are the two properties of set. Okay. Now with that, let's see how to represent a set. So if I have to say set, okay, it uses your curly bracket to represent. Now, in dictionary also we have used curly bracket. So this is your second usage of curly bracket. Okay. So you put curly bracket, and then you put values here, 2, 4, 6, 8, let's say. Now when I print set 1, okay, you see, did you see this? Do you think is it same order in which we have declared the set 1? No, right? We have declared 2468 and output is 8246. You run it again, right? So this shows that order doesn't matter, right? That's what we discussed. In set, order doesn't matter. You both can speak, okay? Okay. Um, okay. So so if I have to get 4 out of set 1, can I get 4 out of set 1? Indexing, right? You remember, right? We did indexing using square bracket. Can I do indexing here?
If it's not ordered, maybe not.
Maybe not. Yeah, it's not. We cannot do it. Okay. Because logically again, okay, set means you gave me 4 numbers. If you give me 4 numbers, I should not be able to change it. I should not be able to do that. But there are other operations that you can perform on set, right? So you have, what are the set operations that you have discussed? We are, in maths class, you have union, intersection, right? Minus. So these are the operations you can perform on set. So let's say you have set 1 equal to, okay, set 1 is 2, 4, 6, 8, and set 2 is equal to, let's say I give 6, 8, 10, 12, right? So first one is union. So you can say set 1 dot union set 2, or you can even say, okay, so before I do this one, what does union mean? Union means combine the values, isn't it? So when you have set 1 and you have set 2, union would combine the values from both the set and create a new set, right? Create a new set. So in this case, okay, 2, 4, 6, 8 and 6, 8, 10, 12 should give us what? If I print, what should I get? Manmeet, you there?
Yes, I'm there.
So what do you think you'll get?
2, 4, 6, 8, and 12.
Exactly. Okay. Duplicate values will be appearing only once. So this is one way to use the inbuilt method, okay, union, or you can say set 1, pipe, set 2. Okay. This is another way of doing union. So pipe operator will also do union. Then you have intersection. Intersection is used to find the common element between them. Okay. So, okay, and here you use and sign, ampersand sign. So common elements are 6 and 8. So you run and you get 6 and 8 here as the output. Okay. The next one is minus. Now, intersection and union, it doesn't matter whether you do set 1 union set 2 or set 2 union set 1. Okay. It's going to give us the same result, right? Same thing with intersection. Set 1 intersection set 2 or set 2 intersection set 1 going to give us same result. But then you have minus or difference. Okay. Difference is different. Okay. So if I take this here and instead of intersection, I say difference, or I use minus sign here. So I'm saying from set 1, remove set 2. So this is set 1. So 2, 4, 6, 8 minus 6, 8, 10, 12. So minus 6 minus 8 will go away, right? But what about 10 and 12? Okay, you do not have, let's say this is you and you do not have 10 and 12. I'm asking you to give me 10 and 12. You cannot give me, right? You do not have 10, 12. How can you give me 10, 12? So this will not have any impact. So when I say set 1 minus set 2, I should be getting only 2 and 4, right? Because 6 and 8 goes away. And anyway, 10 and 12 doesn't have any meaning for set 1. Now, if I do set 2 minus set 1, what do you think the output will be?
10, 12.
10 and 12. Yes. Okay. So 6 and 8 will go away and no meaning for 2 and 4 for set 2. You get 10 and 12. So these are the three main operations that we perform on set. Each of these three also has something called as symmetric. Okay, now let's perform symmetric and then we'll see update. Okay, what symmetric does, okay, symmetric difference does is, now, as I said, set 1 minus set 2 is different than set 2 minus set 1. But now when you talk about symmetric difference, they will be same. So it's like union of two differences. Okay, so here you will say symmetric difference. Okay, and here you have, I think, this caret sign, the up sign, up arrow. Okay, so union. So first you get 2, 4, then you get 10, 12. So it is 2, 4, 10, 12. Symmetric difference. Okay, so if I have to represent this as Venn diagram, right? So you all know, right, Venn diagram. So set is generally represented using Venn diagram. So let's say if I have, okay, this is set 1 and this is set 2, right? So when I say symmetric difference, okay, then I'm talking about, you know, this area plus your this area, right? This is what you get. You don't get this common intersection part. Okay, but if I talk only about difference, okay, so this is if you set 1 and this is a set 2, okay, then I'm only talking about this one. When I say A minus B, if this is A and this is B, A minus B, okay, this is A and this is your B, right? So if I say A minus B, this is what you get.
I can't see anything. Are you
No,
print?
you
I mean,
can't
like,
see.
are you?
No.
Yeah.
Yes, sorry. I think I did not share the entire screen. Sorry. Sorry. Now I should be able to see this.
Yeah.
So this is your symmetric difference. So when I say A minus B, right? So A and B, only the non-common part is selected. But if I say A, B, A minus B, this is what you will get, A minus B. Okay. Going back to the program here. Yeah. Now, so I was saying that each of these 4 has something called as update. Okay. So you have, for union, it is only update. Union is only update. And for rest, it is like, you know, it is like intersection update. Okay. Difference update. Symmetric difference update. Okay, what does this mean? It see, so far when we are doing these operations, whether you are doing inbuilt method or you are doing this operator, in all cases we are getting a third set. We are getting a third set. Okay, your set 1 and set 2 values are not impacted. So set 1, set 2, if I print here, if I print set 1 or comma set 2, okay, you will get same set of values. So original sets are not modified, not impacted when you don't use update. When you say update, update will not give us new set. Update doesn't give new set. It changes the main set. That means if I say set one dot update set two, so it will perform union of set one and set two, and set one will be impacted. Set two will remain its own value, will have its own value, but set one values will change. Okay, so if I say set one dot update set two, now if you print set one, comma set two, okay, it's no longer okay, so this is, will print this before doing update, and this is after doing update. So before doing update, you see set one is 2468, right? But after update, the union 10 and 12 also got added to set one. So update will also impact your original set. But if you don't use update, okay, then your original sets are not impacted and you end up getting a third set. So if you do not want third value and you want to update the original first set itself, then you use update. So you use only update. So only update means union update. And for everything else, you have intersection update, difference update, symmetric difference update, right? Which will update the set one. Okay, so these are the main inbuilt functions that we have in set. Apart from that, there are some other methods which will give you true or false. So you have something like set one dot, okay, you have pop, remove, okay, clear. Clear will remove all the elements. Okay, it will make a empty set. Remove takes the element. So I want to remove 8 from this set. So I'll say remove 8. Okay. Now pop here, okay, pop is like removing any random value. Okay. So if I ask you name 5 fruits, and now I change my question, I say, no, don't give me 5, you give me any 4. So you can delete any one, isn't it? You can delete any one answer. So that's why pop doesn't take any other value. Just say remove any randomly, any one you remove. So pop will remove randomly any one value from the set. Then you have update, symmetric update, etc. And you have this is superset, subset, is disjoint set. Superset means what? So if I again go back to this diagram here. So let's say I have a set and I have another smaller set. And let's say this, I call it as B. And this is A. That means A is subset of, A is superset of B and B is subset of A. Right? So if I create a set 3 equal to 2, 4, right? So set 3 becomes subset of set 1. Set 1 has 2, 4 and other elements. So set 1 is bigger. Set 3 has just 2 and 4. So set 3 has become subset and set 1 is superset. Now if I create set 3 also with same values, then set 1, set 2 both are superset of each other, both are subset of each other. Disjoint means the intersection is 0. There is no common element between them. So we say disjoint. Right? So these are operations that you perform on set. Now, one thing you have to remember is we can convert sets to list and to tuple directly. Okay, so sets can be converted to list, sets can be converted to tuple, tuple can be converted to set, list can be converted to set. So if I have to convert set to tuple, I'll simply say tuple of set one. I can say simply list of set one. Now, if you want to convert it back, you say set of list or set of tuple. So if you want to use list like functions in set, you can use it. But first you have to convert set to list, and then you add, you get access to all the functions provided by list. You do the list work and then again convert it back to set. So all these functions are available, like set can be used at list can be used at set, but you have to perform that extra step of converting list to set or set to list. Make sense? So with that, we complete our set operations, and these are pretty much it.
Okay.
Oh, one sec, sorry.